So what do you think of the inverse trig functions now? Let's have a look at the inverse of cos, arccos. So I'm going to build this graph up in stages. The first stage is to think about the graph of cos x, plain vanilla cos. And there's the graph of cos x. Now, we're looking at arccos, which is the inverse of cos, and the inverse function is the inverse of the part of the original function, which is 1 to 1. So we have to look at the part of the graph of cos x, which is 1 to 1. So we've got to start here and finish there. That's the part of the graph of cos x that has an inverse. So to think of the inverse, just arc cos x, I'm looking at the key points here, here, and here, and look what happens to those. So the left-hand point here, which is the point 0, 1, that will go to 1, 0 here, 1, 0. This point here, which is pi over 2, 0, that will go to 0 pi over 2, which is around about here somewhere, 0 pi over 2. And this point here, pi minus 1, will go to minus 1 pi, which is somewhere up here, minus 1 pi. So when we join these three dots together, we'll get something which looks a bit like this. And we hope that when we've drawn that we get a line of symmetry in the line y equals x. So the two graphs really ought to cross each other on the line y equals x. So here's a rather neater version. So we've got the graph of cos x here and arc cos x here. So I'm going to take one step closer to my goal. I'm going to draw the graph of arc cos x minus pi over 4. So this is a transformation of the graph of arc cos x. It's a translation by pi over 4 units in the positive x direction. So that's what the graph of arc cos x minus pi over 4 looks like. And then finally adding the 2, or rather multiplying by 2, means that the y values are multiplied by 2. So the purple line is going to be stretched by a scale factor 2 in the y direction. So that red graph is the graph of 2 arc cos x minus pi over 4. So we need to find the endpoints of the graph now. To find one of the endpoints, I'm going to track the endpoints of the graph of cos x, starting with this point here, 0, 1. And that transforms, when we go from cos to arc cos, 0, 1 goes to 1, 0. And then when we translate the graph by pi over 4 units in the positive x direction, that becomes 1 plus pi over 4, 0, and multiplying by 2 really is just multiplying the y value by 2, and 0 times 2 is 0. So that's the end point of the red graph there. Then I'm going to track the other end of the graph of cos, this point here. So that's the point pi minus 1, and so that relates to this point here on the graph of arc cos, and that's minus 1 pi. When we translate that by pi over 4 units and the positive x direction we get -1 plus pi over 4 pi, and then we stretch that by a scale factor of 2 to get the end point of the graph there, where the x coordinate is -1 plus pi over 4 and the y coordinate is 2 pi. So we've sketched the graph of that. We've shown the coordinates of the endpoints. We've still got to find the points of intersection with the coordinate axes. There's only one more of those, that point there, and that's when x is 0. So when x is 0, y equals 2 arccos 0 minus pi over 4, which is 4.948 to 3 decimal places. So the coordinates of this point here are that. So how did you get on with that one? I hope you followed the logic there.